Very good morning to all of you. In today's lecture, we will talk about the most important topic of this chapter, that is lanthanoid contraction. As the name suggests, lanthanoid contraction means something is related with the atomic size or ionic size, and the atomic or ionic size contracts or decrease for lanthanoids. So lanthanoid contraction is the term related with the atomic size or ionic size of the lanthanoids. You know it very well that members of 4F series are called lanthanoids, or the 14 elements followed after lanthanum, which is having atomic number 57, are called lanthanoids. Lanthanum with atomic number 57 is a member of D block, and it belongs to 5D series. It is the first member of 5D series, but still it is included with the lanthanoids for study purpose, because lanthanum closely resembles lanthanoids in its chemical properties. Now, why this term is important, that is lanthanoid contraction. Why the decrease in atomic size or ionic size of lanthanoid becomes very important whenever we talk about F block elements. Reason, you know it very well that if we start moving from left to right in a period, there is no change in the valence shell. The extra electron added to the same valence shell, at the same time the proton is added to the nucleus. As there is increase in the number of protons, so the force experienced by the valence shell electrons increases, as a result of which valence shell undergoes contraction, or there is decrease in atomic size. It is a general rule. Whenever we move from left to right in a period, atomic size decreases. But this decrease is not regular. This decrease is not by a constant amount. That's why contraction in any other period, like first period, second period, third period, for S block and P block is not important. But it is important for the members of 4F series as well as the members of 5F series. For 4F we use lanthanoid contraction, and for 5F we use actinoid contraction. Now, what is lanthanoid contraction? So here is the definition: the atomic and ionic radii of M+3 ions. You know it very well that for lanthanoids, the common oxidation state or the principal oxidation state is +3. That's why I have written here M+3 ion. The atomic and ionic radii of M+3 ion shows a steady and gradual decrease in size. In moving from left to right is called the lanthanoid contraction. So when we start moving from left to right for 4F series, there is a steady and gradual decrease in atomic or ionic size. And this decrease in atomic or ionic size is called lanthanoid contraction. Now why it takes place? So before we start the explanation of lanthanoid contraction, let us have a look on energy pyramid. It is the arrangement of subshells in the order of their increasing energy. 1s is placed at the top, having lowest energy amongst all their subshells, while 7p is having the maximum energy. So what is the increasing order? Increasing order is 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p, 5s, 4d, 5p, 6s, 4f, 5d, 6p, then 7s, 5f, 6d and 7p. We are talking about this part 4f, which is present between 6s and 5d. The first member of lanthanoid is cerium, having atomic number 58. And the last member of 4f series is lutetium, having atomic number 71. It means total 14 elements are there. Which elements belongs to 4f series? It's very simple. If the incoming electron or the last electron makes entry in 4f subshell, then the element belongs to 4f. It means electron number 58, that is the incoming electron, will move to 4f subshell. At the same time, one proton will be added to the nucleus. There is increase in the number of proton and one electron is added to 4f. You know it very well that the electrons present in inner shell or the inner subshells exerts a screening effect or shielding effect. But here the shape of 4f is too diffuse. It is having complex shape. It is having complex shape. So electrons present in 4f subshell are not able to screen or shield the charge increased due to the addition of proton in the nucleus. So the nuclear charge is not effectively shielded by 4f electrons. So what will happen? The charge will move out, or the force of attraction will move out to the valence shell electron. With the successive increase in the number of proton, there will be successive increase in the charge or the force of attraction experienced by the valence shell electron, because the electrons in 4f are not able to shield or screen the nuclear charge effectively. So what will happen? When the force of attraction due to nuclear charge increases over the valence shell electron, the valence shell undergoes contraction. This contraction is steady and gradual. And this is called lanthanoid contraction. So when we start moving from lanthanum or cerium to lutetium, there is a gradual and still it decreased in the ionic size or the atomic size of 4f members. So, if you are moving from cerium to praseodymium, one electron is added to 4f subshell and one proton is added to nucleus. But electrons in 4f are not able to shield the charge increase due to addition of proton effectively. So the nuclear charge will move out and it will exert force of attraction over the valence electron and valence electron undergoes contraction. Now when we start moving from praseodymium to neodymium, again one electron is added to 4f and proton is added to nucleus. One more proton is added and we are adding electron to 4f. 4f subshell is too diffuse, too complex. It is not able to screen the nuclear charge effectively. So again, more charge will come out to the valence shell and valence shell will undergo further contraction. So there is decrease in ionic size. Here graph is plotted between ionic radii measured in picometer versus atomic number. 57 is the atomic number for lanthanum and 71 is the atomic number for lutetium. So when we start moving from left to right, there is a gradual decrease in the ionic size of lanthanoids. This is called lanthanoid contraction. Now this lanthanoid contraction is having a deep impact on the atomic size of 5D series also, because it is located between 6s and 5D. When we will talk about 5D members, then 5D members will have extra 14 protons, and if extra protons are there, then force experienced by the valence electron will be moved. So what happens? When we move from 3D to 4D, means we are moving from top to bottom, there will be increase in size, increase in atomic size. But when we start moving from 4D to 5D, the atomic size of the element remains constant, or there is a slight decrease, slight increase. Reason is very simple, because between 5D and 6s we have 4f also. So lanthanoid contraction is having a deep impact on atomic size or ionic size of 5D members also. That's all in lanthanoid contraction. The similar term is actinoid contraction. Instead of 4f, you have to use 5f. And remember one more thing, actinoid contraction is more than lanthanoid contraction, because the spinning effect of 5f subshell of 5f electrons is poor than the spinning effect of 4f electrons or 4f subshell. Thank you and have a nice day.